Okay, to start with, this is all about rational functions. Now, you did have a unit called rational functions last year, and so most of what we're talking about today is review, and then we get into much more advanced stuff, of course, eventually, than you did last year. But if this feels a little bit redundant, it might be because you just have a really good memory of last year. All right, would you agree that this is a butterfly 1 over x function, and it has to be moved? Which way does it have to be moved? To the left for, okay, I'm going to take and make an asymptote set here. I'm going to make this green asymptote for this way and this pink asymptote for that way. And I'm going to move them 4 to the left and up 7. Now I'm going to move my function around. Here, just let me move this out of the way. And move my function to match that. And then left and up. There we go. Okay. So, if I asked you for the equations of those asymptotes, it might be easier to see like how you get future asymptotes out of these. This pink one, it's like the x-axis, so it's not x equals something. Because the x-axis is actually y equals 0, right? So the pink one's a y equals thing. It's actually y equals what? 7. It's that. Do you remember these rules? Bigger on bottom, bigger on top, or same on both? Does that ring a bell for some of you? All right. Some of you learned that last year in my class. Some of you may have learned it some other way, but this is the way I'll try to teach you. Would you agree that the bottom part here has a degree of 1 and the top part does not have any x? And therefore, you could argue it has an x to the 0, but it has a degree of 0. And so this one's bigger on the bottom because its degree is bigger on the bottom. So there's 3 cases. A function can either be bigger on the bottom or it can be bigger on top, or it could be the same on both. So I'm going to give you those 3 cases. Bigger on bottom, bigger on top, or same on both. All right. So this one, it came out with y equals 7, and it's one of those kind where it'll be whatever's on the outside. Next, let's talk about this green asymptote. The green asymptote is an x equals asymptote. It's at x equals -4, and that came from there, obviously. So, here's the quick answer. Verticals are whatever makes the bottom 0 unless it happens to be a hole, and I will show you those in a second. So this is where the vertical asymptotes or holes come from. And this is where the horizontal asymptotes come from. Okay, so I'm going to give you one. I want you to tell me just change the number up a little bit. There. What would this one's horizontal and vertical asymptotes be? Maybe you're not ready yet, but this is kind of where we're going to be going. So some of you will be able to handle it. Horizontal and vertical asymptotes. The horizontal asymptotes are the ones that depend on the whole bigger on bottom, bigger on top, or same on both thing. Is this one bigger on the bottom, bigger on the top, or same on both? Bigger on the bottom. And so, if it's a bob, I'm going to give you those 3 rules now. There's bigger on bottom, bigger on top, or same on both. If it's a bob, it's y equals the outside. It's whatever's outside the rational function. That's your asymptote line. Well, you might be like, there's nothing outside. So what is outside then? 0. So y equals 0 would be this guy's asymptote, because it is one of the ones that's bigger on the bottom. Now, what are the other options? Well, if this happened to have had an x to the third on top, then it would be bigger on top, right? Does anybody remember the deal for bigger on tops? All right. For a bigger on top, there are no asymptotes. So it's, instead of saying bot no, I like to call it no bot. It's kind of like robot. Try to make that stick in your head. There's no asymptotes for bots. There aren't any horizontal asymptotes if it's bigger on the top. Let's think about an example of that. Y equals 2x squared, and there's no bottom. Well, it's clearly bigger on the top. If you want to put a 1 on the bottom, that's fine, but it's still going to be a bigger degree on top. That's a bot. Do you know of any asymptotes in the parabolas? No, there aren't any. It's because it's a bigger on top. There aren't any asymptotes in that kind. All right, how about same on both? That'd be like this. They both have an x to the third. So that's the same on both. You're right. If they're a same on both, those are y equals a ratio of the LCs. What do you think LC stands for? Leading coefficients. Now you need to have these written down because this is not something that people just remember easily from year to year. In fact, just a moment ago, everybody who learned this last year and was tested on it, and most of you guys probably even got A's on that test, have forgotten it, and it's normal because your brain slowly lets go of information it feels like is not important, and the way you can tell your brain something's important is by making it recall that, and you probably haven't made your brain think about a horizontal asymptote since about this time last year, because it's about right now that we start learning that stuff in higher algebra. So, not like right now, but it was not at the very end of the year. Okay, so that's how the rules for horizontal asymptotes. Why don't we, on the same page, make the rules for vertical asymptotes? The vertical asymptotes, they make the function crash. What do I mean by crash? Well, the function won't exist there. I'm not saying make it 0. I'm making it divided by 0. Do you get if I put in a 5? This function is allergic to 5s. Because if I put in a 5, you'll end up with a 0 on the bottom and there's no answer. All right. So, there's horizontals, verticals, and then there's one other thing that you have to know about, and that is something called a hole. The best way to show you an example is to show you an example. The best way to explain this is to give you an example. If I had x plus 5 over x squared minus 25, do you remember seeing stuff like this on the top 20 where you got like this factor on the top and then there's something else can be factored and then, things can cancel, and if you can factor it, you should. And now that cancels that and it just created a hole in the function. This would make a hole not at 5, a hole at x equals negative 5. Positive 5 is this guy, and it still causes a problem, but it's not a hole. The one that was the hole was this one, and that negative 5 is the culprit there. Okay, so these things on the bottom that crash your function, either make holes or asymptotes. This one made a hole. This one makes an asymptote. Is it one of those vertical asymptotes? It is. It's not a horizontal one. Horizontals you'd be doing with bigger on bottom, bigger on top, or same on both. For verticals, they make the function crash. They're things that make the bottom 0. Okay, so I got one really good example I want to give you that's got it all. It's got holes, it's got asymptotes, and you can do the whole bigger on bottom, bigger on top, same on both thing for it. Okay, ready? Wait, put that on the bottom, sorry. You can put an x plus 4 on the top. Now, here's a typical question. What's the vertical asymptote? Is there a hole? What's a horizontal asymptote? And remember, Bob's the one in charge of the horizontals. Bob, Sob, or Bob. Okay? And then, graph it. Don't forget, the XY chart's your best friend for graphing. So, let's see if you've had enough instruction that you already understand this. I'm going to pause for a second, give you the try. Okay, now that cancels that, and that creates a what? A hole. And the hole up here is at x equals -4. And would we be so mean as to make you find the y value? Yeah, we even did that last year. If it was -4 comma something, what would the other part be? Well, you know the x, so you can stick that in and find the what? The y. It's not that hard. So if I have this equation now, that the stuff canceled, I have y equals 1 over x minus 4. Remember, -4 is not going to crash it anymore. It would have in the original. So now I stick in -4 into what's left, and I get 1 over -8, -1/8. I didn't even teach that in my other class today because I don't think they're going to make you know that today, but they will make you know that by the time we take the test. So that went over your head. I will be re-explaining that again tomorrow. The vertical asymptote is the other thing. This canceled made a hole. This one makes the vertical asymptote. So what about that? It's a 4. So x equals 4. It's a line. It's a vertical line. It's a dotted line. If I was going to graph this, which I'll have to do eventually, I'll move this down here. It's a vertical line at x equals 4. Like that. Okay. Horizontals. Bob. Bob is the expert on horizontals. Is this bigger on bottom, bigger on top, or same on both? All right. If it's bigger on the bottom, then what's the rule for Bob's? Remember? It's whatever's on the outside. Here's my function now that this has been cleaned up, this black function here. How do I find out what's on the outside? Well, there's nothing on the outside. So what's the answer? Nothing? No. 0. So it's y equals 0. And graph it. Well, I got this dotted line here. Ooh, I recognize this one. 1 over x, except moved 4 to the right. So that's going to be an easy one. I can say there's an asymptote here, which is at 0, which, like I just said that up there, but I should put it on my graph. And now this is this guy. Right? It is. And if you had questions about that, you're like, I'm not sure I'm doing this right, or maybe you didn't remember that. XY chart's your best friend in graphing. You'd find a few points near the asymptote. Since the asymptote's at 4, you might try like 5. And you put 5 in and you get 1 over 1, which is 1. 5 comma 1. Right there. So you can always get these with an XY chart. Yes?
You have to draw.
Yes, you're absolutely right. I'm not done yet. Now I'm going to put in 4. And, 4 makes the asymptote. It's okay to put that on a chart. 4 is the asymptote. Then I should put in 3. And then I'll put a 3 here. 1 over 3 minus 4 is 1 over -1, which is negative 1. 3, negative 1. That's that spot there. Cool. This is all shaping up. And it'd be very easy to forget what you just said, which is this thing has a hole. That hole is at negative 4 comma something. So way over here, empty spot, and then it just keeps going. Now, this is an interesting theoretical thing. Hole is just the number negative 4 is the only thing that will crash it. Do you know how wide that is on a number line? How wide is the spot negative 4 on a number line? Points are infinitely small. So therefore the hole is infinitely small. But you cannot use that argument on a test for why you forgot to draw the hole in. Oh, it's there. It's just infinitely small. Preemptively saying you can't use that argument. So it is so easy to forget that there's a hole in the graph, and I know a lot of people will. One good thing is the math department talked about this, and we decided, even with our grading system, that you get one free mistake, and 75% of the hard one gets you an A. We still can do part credit for something like that, where you've done all the work. There was a ton of work. The verticals, the holes, the horizontal, and then you just forget it. The one thing on graphing it, you're not going to get the whole thing wrong. But you are going to, minimum, we can take off, is 5%. So you lose 5% for something like that. So if you were going to have an 85, now you're down to an 80 because you forgot something like that. So math rewards careful people. And so you got to be just really careful. So when you're done, try to watch out. The hole is easy to forget. Okay, so now let me give you one that isn't bigger on the bottom. Would you tell me vertical asymptotes, horizontal asymptotes, holes, and a rough idea of where the graph is? If you got vertical and horizontal asymptotes, put them on there. And then if you're lost on what this thing looks like, XY chart. This is a typical question. Pause for a second when you work that out. Good one. Okay, so I'm back to saying that this and this are the same degree. So this is the same on both. And does anybody remember what the rule for SOBs are? Ratio of the lead coefficients, and therefore 3 over 2. Y equals 3 over 2. What does that mean? That means on the graph at 1.5, at y equals 1.5, there's this dotted line going across like this. Asymptote. Okay, there's a hole at 0. I'll do that at the end when I actually have a graph to put a hole in. And then there's no vertical asymptote, just a horizontal one. That's kind of weird, but it happens. And now, where is this graph? Is it going like this? Or is it going like this? Or what is it doing? Well, I don't know. I don't have this one memorized. X squared over x squared? That's not in my wheelhouse. So, what am I going to make, do you think? XY chart, your best friend in graphing. So, I'm going to put in 0, and I'm going to, I get a 0 on top and a 0 on the bottom. Wait a minute. If there's a 0 on top and a 0 on the bottom, that's the hole. There's a hole at 0, 0. So I'm going to put an empty spot right there. I'm going to try putting in 1. If I put in a 1, I have 3 plus 3 is 6 over 2. 6 over 2 is 3. 1 comma 3. Over 1 up 3. Did that go over that line? Yeah, that line's at 1.5, so it's like here-ish. And now I'm just going to put in one more point, a little bit bigger. I'll put in a 2, and I'll see if it ends up going up or down from this spot. Okay, so now I'm going to put in a 2. And I get 4 times 3 is 12 plus 6 is 18 divided by 4 times 2 is 8. 18/8, which is 9 over 4 which is basically 2 and 1/4, 2.25. So it was over 1 and up 3. It's slowly falling, which means it'll keep falling and get closer and closer to the asymptote, and there. Now, one more thing. Remember, this graph can't cross this line. Why not? Because as soon as you put in x equals 0, crashes the whole function. Fails. There's a hole there. All right, so I know it's going to move towards this line, and we can assume the curve's going to continue in the same direction, but it's not going to hit that spot. All right, how about some other points, Mr. Server? How about you make your X supply chart bigger? I'll just move another one over here, and I put in -1, and I see what happens. -1, -1, -1, and this will be 1 times 3 is 3, plus -3 is 0. And 0, as long as the bottom isn't 0, which it isn't, 0 over anything is 0. Cool. -1, 0. My guess is it's going to pull one of these, like that. But I don't know yet until I actually make a couple more points. So I'm just kind of guessing there. So how about if I put in -2? Last one I'll do. I'm just trying to make the point that these are not something I expect you to memorize, but these are something that the XY chart can tell you. All right, so then I have 4 times 3 is 12, and -6 makes 6. Over on the denominator, I have 4 times 2 is 8, 6/8. That's the same as 1/4. And, yep, it's just a little tiny bit above there. Oh, 6/8, not 1/4, is it? 3/4, sorry. All right. So that's moving up this way, so I was right. It's going to get closer and closer that way. And I know it can't hit this line, so it's kind of got to go that way. And there we go. Yay, got my graph. I even have the hole in there. That was a weird one. But it's so weird that it'd probably be too hard for a test. But I showed you how with an XY chart you can figure out where it is. All you got to do is connect dots and know how things get closer and closer to an asymptote. Okay, so your homework is, if you look at the file posted for today, on page 6 is where the homework starts. On page 6, you have problems 1, 3, 5, and then you're going to skip until you get to 9. So you're doing problems 1, 3, 5, 9. And then there's one about an invasive species fish, and I don't remember what problem number it is. 19. Okay. So 1, 3, 5, 9, 19. And considering how little time we have left, I'm just going to stop it right there for your class. 1, 3, 5, 9, and 19. That's 5 little questions. Okay, and that is all I have for you for today.